Welcome everyone to the webinar. We're still waiting on a few people to join, so we'll have about 3 minutes of wait. And I'll see you in about 1 minute and we can start the talk, but the official webinar will start in about 3 minutes. So hello everyone. We're still waiting 2 minutes for the late people. Right now, I'm just going to quickly introduce myself. I'm Louis, for those who don't know me. I'm the director of the Vietnam agency, and I'm also in charge of the international business at the company. So I will be the host today. I'm not going to be speaking. That will be Jean-Philippe Delhom. And since we have a bit of time waiting for the webinar to start, I'm actually seeing already a lot of people from different parts of the world. So good morning, good afternoon. If you can share in the chat on the bottom right where you're connecting from, that's actually quite interesting to see. I see people from India, from Helsinki. Hello, Arif. China, Shanghai, Italy, UK. Okay, very nice. Vietnam. Okay, Miss Luan, hello. Privyet. From Russia, we have Luxembourg. Okay, we have Saudi Arabia. It's quite a diverse group today. Some people I recognize, some people I actually first time. From Portugal, very nice. Okay, very nice. Paris as well. Hello, Baptiste. Netherlands. Whereabouts in Netherlands? Very nice. Okay, so we have 4 seconds. All right. So the before we go into the core of the presentation, I just have a screenshot here of what you should be having on your screen right now, and we highlighted in red the important buttons that you can interact with. So on the left, you see the full screen button. If you want to see the presentation in bigger, if you haven't yet, you can click that and it'll be a little bit bigger. And on the right here, we have the most important buttons. Here we have the polls, where basically throughout the webinar, we're going to ask you a few questions. You can vote. I will let you know when the poll is open for each question. And then if you have questions that you'd like to ask Jean-Philippe during the webinar, feel free. You can write your own questions. The other attendees won't see them. We'll just answer them at the Q&A section at the end of the webinar. So throughout each different chapters that we cover, you can ask questions. And at the end, at the bottom right, you see the chat, which you're already using and familiar with. So now I'm going to introduce Jean-Philippe Delhom. But before I do, actually, sorry, we have a poll. I'm going to share now the first poll question. Here we go. All right, so I've just published a poll in the poll section. You can vote. The first one is, how did you hear about this webinar? I know we've done several campaigns for emails, for LinkedIn. So let us know in the poll section, and also you will see if it works or not for you. Okay, so welcome, Jean-Philippe. Thank you for your time today.
Hello, everyone. Thank you, Louis.
So today, Jean-Philippe is going to talk about the 8 tips on how to properly manage the acoustics of your building. Before we go into that, just a quick introduction about Jean-Philippe. Jean-Philippe started his acoustic career in the 1980s, and then in 1995 he started Delhom Acoustics, and he's now the founder and CEO today. And he opened in southwest of France, in Toulouse, then opened some agencies in Paris, Shanghai, and Ho Chi Minh City. And from these agencies, from these 4 offices, he's been able to work around the world on a lot of different types of projects. And that's how today he's able to share with you very interesting information and insights and anecdotes that he's had throughout his career. So without further ado, Jean-Philippe Delhom, thank you very much. And we would like to also just quickly present the 4 sections of the webinar. The first one is actually the importance of acoustics. You can see here on the screen. Jean-Philippe will talk about why acoustics is an important factor for a project success. The next part is the main acoustic issues. Very quickly, what are the issues we find in building acoustics? And third, it's going to be really the 8 tips and practical advice that you can use on your projects. And finally, the Q&A section. So get your notebooks ready, get your pens ready, because there's going to be a lot of useful information. Thank you very much, Jean-Philippe, and thank you all for your time.
Thank you, Luis. So the first part of the presentation, as Luis said, is about why acoustic is so important in our project. So I want to share with you some key facts. Like the first one is from the World Health Organization that revealed noise is the second largest environmental cause of health problems, just after air pollution. That means it's a really important issue on health. And there are studies like this one from the University of Sydney that shows that the impact of noise on health is multiple. It impacts our stress level. It has also physiological impacts like on blood pressure. It provokes sleeping disorders and also impacts our social behavior. But it's not only about health. Noise has also big impacts on our productivity at work. And this study from Steelcase Ipsos is showing that employees lose on average 86 minutes per day of productivity due to bad acoustic design. So it has a very big, strong impact on productivity, and it has a cost. Also, for workers in offices, this study shows that the lack of sound privacy is the biggest frustration among workers. We know that this frustration has a very important link with the staff turnover, for example. So again, noise has an impact on our companies. But not only about productivity, I choose here some example about reviews we can easily find on the internet about, for example, here, hotels or restaurants. And it's really not good for the customer experience or the brand image when we can read these type of comments. We know that it will be difficult to get new customers or even to keep our existing customers. So yes, really, noise has multiple impacts, bad impacts. So this is the reason why it's so important to manage it properly in our project. We could go on with many other examples, but I choose these few ones. So what are the main acoustic issues we need to deal with when we design a building project? There are usually 5 main acoustic issues. The first one is the sound insulation. Sound insulation is the capacity to separate noise between 2 spaces to keep a good confidentiality or privacy between 2 spaces. Then we have the noise from the technical equipment, because every building has its own ventilation system, its own heating, cooling system. Sometimes we have energy generators. So these equipments make noise, produce noise and vibration, and we need to deal with it if we want to have a good background noise or a comfortable background noise. The third one is about impact noise. So this is usually the noise from footsteps, for example, or moving furniture. It's mainly in sensitive buildings like residential, hospitality, not so much in offices, but sensitive areas, we will have to deal with this type of impact noise. The fourth one is about reverberation. So later in the presentation, I will explain a bit more about what is reverberation. But to summarize, it's linked with the global atmosphere we have in a room. It has an impact on speech intelligibility. It has an impact on sound propagation. So it's very important to control it properly. And finally, the last issue we need to deal with when we design a building is its impact on the environment. Because as we said earlier, we have technical equipment that generate noise. And in most countries, we have regulation that will give targets in terms of noise at the site boundaries or even towards the building around our own project. So it's important to know these targets and to deal with the noise to comply with the regulation. So now it's poll time.
So now we have another poll question that you can access in the poll section at the bottom right of your screen. Which of the noise issues that Jean-Philippe explained in the previous slide, which ones of these do you encounter the most on your projects?
Thank you, Lois. So now let's start the important part of this webinar. I'm going to talk about 8 tips or advice I choose to help you to manage properly the acoustic of your building. It's based on my experience, problems I've seen many times. So this is the reason I choose these examples. So the first one is about avoiding over-technical design. Because in acoustics, it's not only acoustics, but in acoustics, it's very important. I've seen many times that when we want to deal with a specific issue, we very commonly see over-technical design. So I choose one example, but about sound insulation, but it could be about any other types of issues we have in acoustics, in building acoustics. So here we have 2 rooms, one office and one meeting rooms, and our client wants to have a good confidentiality, good privacy between the 2 spaces. They want to have a good insulation. So very commonly we will see that the design team will focus on the partition. It's quite obvious, if we want to have good privacy, if we want to not to be able to hear what is being said next door, we need to have a good partition, which is true. But very often at the end of the project, when we do the acceptance, we see that we can still hear what's going on next door. It doesn't work, even if we put some effort on the partition. And the reason is that we often forget other paths of sound transmission. For example, here we can have noise going through the ceiling. We can have noise through the slab, and in fact, through all other parts of the buildings. It's called flanking transmission. It can also be transmission through defects, like here, electric circuits back to back, then noise will go through. So even if we have a very strong and performant partition, at the end, we might not have the expected results. So for this example, which is a real one, I will give you the case study we did. So we were looking for performant global insulation around 40 decibels between the two spaces. And that was the need expressed by the client. So the technical team designed a very performant partition, 60 dB, double stud, and thickness 200 millimeter, which means that we got the 60 dB insulation. But when we did the simulation of what was proposed by the team, we realized that we got 43 dB, which was good. This is the global insulation. 43 dB was good because we were looking for 40, so it complies. But we were surprised that using a 60 dB high performance partition, we only got 43 dB at the end. So we went into the details. With our simulation, we could see where the sound was going through, what were the paths, and we realized that at this stage of the insulation, the partition was not the weak point. In fact, we had other transmissions through the slab mainly, and then the need of such high performance partition was not real. So we ran other calculation, and finally we got a partition that was much thinner and much cheaper. 47 dB was sufficient, and the result of global insulation we got with this partition was the same, 43 dB. So it means that we were over designing this partition because we didn't see the other paths and the other weak points. So doing a proper technical design for this partition with the simulation allow us to save money, of course, but to save space because the final partition that was chosen was only 12 centimeter instead of 20. So we also save some space in the project. So I like to use this image because here it's quite obvious. Everyone can understand that if you want to increase the capacity of the bucket, you need to focus on the weak point. We can see here that it's no use to add things on other parts of the bucket. Unless we treat the weak point, we won't get a better capacity for the bucket. It's the same on the acoustic issues, but the difficulties in acoustics is that the weak point is not as obvious as on the bucket. So this is why I often see projects where we have huge over design. So we spend a lot of money for nothing. And this is some advice I think it's important that you have in mind. In acoustics, the weak points are not as obvious as here on this bucket. So the second advice I chose is about how to treat the reverberation using the right material in the right place. And again, here I choose this example because I have seen many times big mistakes about the treatment of reverberation. So before we talk about my advice, I would like to just remind you what is reverberation. So I'm going to play two short videos explaining what is reverberation. So the first one is a recording in a very high reverberant room, and the second one is a recording in an anechoic room, that means very low reverberation.
I'm in the reverberation chamber at the end of Edinburgh. Here the walls and the ceiling are all plastered to give maximum sound reflection.
I've come through now to the anechoic chamber. Anechoic means non-echoing. The walls, the ceiling, and even the floor in this chamber are lined with foam wedges which absorb the sound.
So here, I guess you can all hear the difference. There is a big impact on speech intelligibility. And now I'm going to play a video of a real case, because this is a bit extreme. It's in a laboratory, but in real life, we have some impacts with reverberation. So the recordings I'm going to play now, it's It's a real case. It was in a coffee shop, a very famous brand, where our clients was complaining about reverberation, the noise, and a lot of people were complaining, the users, customers, and also the employees. So they asked us to design a proper acoustic treatment to make the space comfortable. And we had the chance to make a recording before the renovation and after. So I'm going to play the two recordings. They were made in the same situation, same time of the day, same amount of people, and there is no trick. It's real recordings. So you will. I hope you can hear the difference between the two parts. So I guess you could hear the difference. It's we see that it has an impact on clarity, but also it has an impact on sound level, global sound level. So the difference, I hope you could hear it. So it's just to show you how reverberation can impact our real life. But it's true in meeting rooms. It's true in restaurants, of course. It's true in lobbies, everywhere. In fact, in every spaces where we have to interact with people, the reverberation will impact our comfort and well-being feeling. So we will talk about the materials, but first I'd like to remind that the sound is made of frequencies. We have infrasound that we usually cannot hear. It's below 20 hertz. We have the very, very high sounds that are called ultrasounds that we normally cannot hear. And we have what we call the audible sounds between 20 hertz and 20,000 hertz that we normally can hear. And within this audible sound range, we have low frequencies, like this one. I don't know if it plays. It doesn't work, but so we have different frequencies, low frequencies, medium frequencies, which are the human voice range frequencies, and the very high frequencies. And acoustic materials, and all materials, in fact, have different properties. We have materials that are absorbing in low frequencies, like the membrane absorbers, gypsum board, plywood boards, for example. We have what we call cavity absorbers. They are perforated gypsum board, perforated metal, perforated wood, and they will absorb low and medium frequencies depending on their perforation rate and what is behind. And we have also one category which is called porous absorbers that will mainly absorb medium and high frequencies. But this is very simple. All materials have different properties. And I will share with you a real case study that we had where we can understand why we need to pay attention to the right materials. So here we had a meeting room. Our client had a meeting room, which was very uncomfortable. High reverberation, glass, gypsum board, concrete, and people didn't feel comfortable. It was very difficult to communicate, to have a video conference. So they identified the problems. They said, okay, we have too much reverberation, so we need to treat it and add acoustic materials to absorb this reverberation. So they did it. They used PET panels, which are known as absorbent materials, and they didn't get any good results. In fact, the meeting room was worse than before. People didn't want to use it, and they didn't understand why. They said, okay, we had too much reverberation, we had acoustic materials, and then it's worse. People don't want to use the meeting room. So they asked us to study this room, to really study the room and understand why it didn't work and what could be done to solve it. So we did a small study about this, and we realized, as you can see on these curves, the red curves is the reverberation they had before the treatment. So they were right, too much reverberation in some frequencies. And the blue curve is the reverberation they should have. That is the ideal target in terms of comfort, of speech intelligibility. So they were quite far, so the idea of adding materials was not bad. But the mistake they did is they didn't pay attention to the properties of the material they used. They choose PET, which absorbs high frequencies. So we can see here that they correct properly the high frequencies, but they almost didn't have an effect and an impact on medium and low frequencies. So what they did is they unbalanced the reverberation, and that made the comfort really poor, very bad. In fact, it was worse in terms of feeling. It was worse than before. So here the solution was to use materials that could cover medium and high frequency a lot and reduce a little the reverberation in low frequencies. So here the solution we calculated was made of 3 different types of materials. We could absorb properly all the frequencies, low, medium, and high frequencies, using different types of properties in materials, the right quantity for each, and then we got ideal result. So what I want to say here is that acoustic materials, acoustic solutions are maybe similar to medicine. When we all know that when we have a disease, there is no one magical pill that can cure anything. We know that in some case we need to take this medicine, in some other case we need to take another medicine. In acoustics, it's the same. We have different types of problems, different types of frequencies to treat. So we need to know what is the real problem to take the right pill, the right treatment. That's the same idea. Maybe it's not so obvious in acoustic, but this is the same. Now we have a whole time.
That's right. We have another question for you that you can answer in the polls on the bottom right of your screen. It's more about whether you'd be interested to learn more about acoustic properties of the different materials and how they influence your project's acoustics. And also feel free, if you have any questions, to write them down in the question panel at the bottom right of your screen. Thank you.
Thank you, Luis. So now we're talking about the third advice and why acoustic treatments should be integrated in the early design stage. I'm going to give you, to share with you just one example, but the reason I choose this advice is because it's very common that we see projects where the acoustic consultant is on board once the design is almost finished, because a lot of people think that acoustics is something that we add at the end that can solve all the problems. But in fact, acoustic design is part of the design. It should be, and we'll see why, integrated at early stage. So here we had a project of a conference room. We were on board very early at the concept stage, and very quickly we did a simulation of the proposed shape of the room, and we saw that we had a very annoying floating echo. So the floating echo is the sound bouncing between 2 parallel walls, and it's really affecting the comfort and even the speech intelligibility. So at the stage of the project, it was really early concept design. It was easy to solve this issue by changing slightly the angle of the walls. So that was a free solution. It was very simple. But if the acoustic consultant, and in this case it was us, was on the project at schematic or detailed design stage, then the only solution would have been to add acoustic materials, absorbent materials to kill the floating echo, and then it means that it would have an impact on the cost, but also on the design. So this is just an example to illustrate how important it can be to have the acoustic inputs at the early stage. And there is also one other reason is the way we can integrate acoustic solution into the design. Here I'm sharing with you pictures of project we did. So you have on the left the initial renderings that was done by the architect and the interior designer at concept. And on the right, you have the real picture of the project at the end of the project. And as you can see, except maybe the colors of the chairs and the table, it's the final solution completely respect the initial design. And this is only possible because the acoustic solution were taken into account at early stage. So we knew that the designers wanted to use wood for the ceiling, use some panels on the walls. They were using some lighting, and we could integrate acoustic properties in all the solutions, all the materials, because we knew what they wanted. Another example here is a project we did in Shanghai. It's a very famous social network brand, where we were on board very early. And on the left, you have the renderings from the concept, and on the right, it's a real picture of the project. And if you don't know, you will not notice the acoustic treatment, but they are integrated completely into the design, and the space is really comfortable. So that's another reason that acoustic design should be integrated early in the design, so it won't affect the design, it won't affect the cost of the project. And in order to do this acoustic design, we use simulation tools that along the design phases will allow us to check that the material we choose, all the solution we integrate into the design will comply with the targets we have defined. So we can see different simulation of reverberation, and at the end, something that is quite ideal. But again, it's a work with the interior designer, with the architect, to integrate the solution into the design and not add the solution after the design is finished. And our poll.
We have another poll question, guys. At what stage of your project do you usually incorporate acoustic consultants? It's actually very interesting to understand how you work, if you've worked before with acoustic consultants, because as you've seen in the previous chapter, the earlier is best when you want to integrate the acoustics hidden into the design. So feel free to answer that in the polls on the bottom right of your screen. And if you have any questions about this previous chapter, feel free to ask them as well.
Thank you, Luis. So advice number 4 is about anticipate the noise of technical equipment. Again, here, I've seen many projects where the technical equipment were not taken into account in the acoustic design of the project. So the technical equipment, as we already talked about, are almost on all building projects. We need ventilation, we need heating, air conditioning, and so it's usually big equipment that make noise and that can affect the neighborhood of the project. And the reason I'm talking about anticipation is because we have the tools. I mean, the acoustic consultants have the means to predict how the technical equipment will affect the environment. So here we have an example of an IKEA project we did recently, where during the design stage, we noticed that the technical equipment on the roofs would have an impact, and strong impact, on some parts of the project. They would be above the limit we were supposed to have on the site boundaries, and they were also affecting a sensitive, I think it was a school, building next to our project. But because it was early stage, it was during the design, it was very easy to move the equipment or to add some technical treatments like sound barriers or silencers, because this was dimensioned properly. If we don't do that at the beginning, and if we discover this type of problems once the project is built, then it's very complex, it's very expensive. we all know that moving a cooling tower will impact the project. It will be complicated to change all the pipes, or sometimes it's even impossible to add screens or silencers because the equipment is not done to support this type of solution. So again, anticipate these type of issues, because it's very simple to treat and solve this issue at the beginning. So the proper process for this type of acoustic issue is first do a simulation of the impact. The acoustic consultant has all the tools and software to make the simulation. Then check the targets, the regulation or the client targets, and then adapt, if necessary, the project again at early stage to avoid the cost and save costs. Another advice about technical equipment, it's about the ventilation, and it's very linked to what I just said. It's easy to solve at early design stage. So ventilation in a building, all buildings have ventilation systems for workspaces or resting areas, and these equipment will generate some noise that could affect the comfort and the users. So I choose one example here is about the airspeed. Very often in projects, the MEP engineers will focus on the airflow, which is very important, the quantity of air that is needed in each part of the buildings to guarantee the air quality. But sometimes we don't have the right airspeed, and it's a problem because the airspeed, if it's not properly controlled, will generate noise, and it's very complex to change it once it's done, because it means that we need to change the size of the ducts. So that's complex, but that's difficult. And when it happens, very often, nobody wants to change all the networks. It's too expensive, too complex. So the people will have to live with the background noise. And it's a real pity knowing that when it's done at design stage, it's very simple to add 2 centimeters to air ducts, for example, and that will solve a lot of problems by the end of the project. Another reason that it's important to take into account this ventilation equipment at early stage of the building, it's because of a mistake I've seen many times, and it's a big problem to solve, is the size of the technical room. In fact, when we design the technical room, we think about the size of the equipment, so we have a good idea of what we need to put inside the technical room, but we very often forget to take into account the silencer, for example. We need to put on the network in order to guarantee the noise level propagation into the network. And then sometimes we have big silencers because we need, for example, a low airspeed, and we won't find the space to integrate the silencers into the technical room. And that means we will have an impact on the design. We have to change things, to change the ducts or modify the implementation inside the technical room. And in some extreme cases, and it happened to me several times, we have no space to put the silencer. So again, the users of the building, we have to live with the noise for many years. And this could have been avoided by just thinking about it at early stage during the design. Advice number 6 is about the definition of proper targets according to the needs of the project. And that's, for me, it's interesting because I've seen many projects where, in fact, even the need from the client was not clear. Sometimes they will tell you, okay, we need a high confidentiality, but what does it mean? Is it 50, is it 40, is it 55? So what we have to do here as acoustic consultants is to really try to understand what is the real need of the project, of the space, and translate these needs into a proper target. And we will see why it's so important. So every space has different needs. For example, here in terms of reverberation, we are not looking for the same reverberation in all meeting rooms, in restaurants or atriums, different type of space, different type of use, different type of geometry. So the targets will be different. So this is important to translate the need into the proper target to avoid over technical design or under technical design. It's the same with installation targets. We are not looking for the same targets, even if we are looking for good installation. It's not the same for an office or a hotel room. And even inside a closed office, we could have 35 dB or 45 dB, depending on the real need of the space. And it is important to know what is the real target, because each dB will cost a lot of money and sometimes space, as we have seen before. And it's the same with the noise from the technical equipment. 30 dB in hotel rooms will be a normal target, but 35 dB in an open space office is sufficient. But in a theater, sometimes we are looking for very low background noise level, 20 dB. Again, important to know what is the use of the space so we can adapt and adjust the target properly. So what we do usually when we start to work on a project, we define a zoning of the different spaces, and we try to understand for each space what is the need, what will be the use of the space, so we can really understand the real need and adjust the target to the real need. So again, to avoid at the end overcost due to over technical design or user disappointment. And here I want to share with you an example of targets that were not really clear. It was a project we did at an international school in Shanghai, where our client was a bit worried about the noise from the road that could impact the buildings and make noise intrusion and distraction for the users. So they expressed their worry to the technical team, and then they designed a very high performance facade that would really avoid the noise to come to intrude inside the building. Then we went on board and we did a simulation, modelization of the project and a simulation of the noise from the road. And we saw that, in fact, all the facades were not exposed the same way. Some parts were highly exposed and some parts were not exposed at all. So this simulation allows us to translate the impact and the needs for each space into proper targets. And if my memory is good on this project, we save around $1 million USD by adapting the facade installation, the performance, the glazing to what was really needed. So again, definition of the need and definition of the right target. So to summarize this advice, I will say that a lack of proper needs and target definition will have two possible consequences. The first one is over technical design, which means a lot of cost and impact on the design, interior design. We can lose also some space, but also under designing, which means that the users will have to live with an uncomfortable building. So when we work on a project, we need to think about what we need and translate it properly into real acoustic targets. So until now, we have been talking about good practice in terms of design, and it's very important. It's necessary, but once the design is done, we need to make sure that the construction document that will be the Bible for the general contractor is properly done. And I'm talking about this advice because I've seen many times that after a very precise, very well done design, we see a lot of mistakes in the construction drawings that are very difficult to change, because the general contractor will follow the construction drawings and documents, and then if we want to change, then we have to pay more, or sometimes it's not possible. So construction document review is a must-have for acoustics. Here I share with you some example of inputs we can provide during the design phase, for example here for partition constitution. So we give the materials, the constitution, the thickness, the technical characteristics of the materials, their properties in terms of acoustics. We do the same for absorption, for the correction of reverberation, localization of the treatment, the quantity, the performances. And this information has to be translated into the construction drawings to make sure that the construction will be proper according to the design. This is an example of construction review we did for a project where during the design we advised for partition 2 layers of plasterboard. But when we went into the details of the construction drawings, we realized that there was only 1 layer. It's a mistake, but if we didn't review it and correct it at the construction document stage, then it's a bit late, because it will be built as it is in the drawings. So that's very important. Here it's quite simple, but sometimes it's a bit more complicated with acoustics. So it's very important that you ask your acoustic consultant to review the construction drawings before it goes to construction. And the last advice I'm going to share with you today is also linked to the implementation of solutions. Once the design is done, properly, once the construction drawings are good, it's important to make sure that the implementation of the solution is correct. And I'm sharing this because we do a lot of work monitoring, and we see every time big mistakes that has to be corrected during the construction, because once it's done, it's very often it's too late. So this is the reason I advise that you always in your project have some technical assistance or work monitoring from your acoustics consultant to make sure that the implementation is well done. And I'm going to share with you some simple example we have encountered in our work monitoring. So here, for example, we had a partition that should go from slab to slab, but on site, because of the pipes going under the slab, the partition was not complete. And because this was inside the false ceiling, this is something that we couldn't see once it's finished. But we wouldn't understand why, knowing that we have a very heavy and strong and performant partition, masonry partition, we can still hear everything that's going on next door. The reason is because we didn't finish properly the implementation of the partition. And this has to be checked during the construction. After, very often it's too late. Another example here is a riser where we have pipes, and our recommendation was to use resilient collar to avoid that the noise from the pipes would be transmitted through vibration into the structure of the building. At this stage of the project, it's quite easy to correct it and to add the resilient part on the collars. But once it's done, it's very often impossible to access the riser or even to change the collar. So again, during the construction, it's important to check all these details. Another example about partition is something we see very commonly on site, is when we have a seal to add to complete the partition. Here, the partition should go from slab to beam. And I don't know if you can see on the picture, but the gap between the partition and the beam was filled with expanded foam, which is very common. I'm sure you have seen it many times on works site. This expanded foam is good for thermal insulation, but it has no acoustic properties. It means that once you finish your partition, you cover with the finish, you won't see anything, but you will be able to hear what's going on next door, because the noise will go through this gap that is not properly sealed. So again, it's important to check this during the construction, because when it's finished, you don't know, and it's very difficult to identify where is the weak point, because you can hear the noise going from one room to another. You see a strong partition and you don't understand why we still have noise, because we can feel that we have a very strong partition. So again, work monitoring, site inspection is very important. It's a key parameter to succeed into our project. And now we have another poll time.
Hi, everyone. I hope that you enjoyed the presentation from JP. Before we move to the conclusion and the Q&A, we'd be very happy to know how much of these tips and this information that JP shared with you were already familiar with, or was everything new to you? So feel free to answer that in the poll in the section on the bottom right of your screen.
Yeah, thank you, Louis. That's very interesting to know for us. So I'd like to summarize what we just talked about with key highlights. And I think that we can group these tips or advice in 3 categories. The first one is, I think, important to make sure that we understand, we clarify the real needs for each space at the beginning of the project. That will allow us to get the right targets, and will ensure the good results at the end of the project, so user satisfaction, and will avoid over-treatments and over-costs. That's, for me, a key point to remember. Second group of advice is about the integration of acoustic design at early stages. Again, it will help to integrate the acoustic solution into the design and not have something that will be added on the project. And this is, for me, it's always a pity when I see the acoustic solution that has been added after everything is finished. It's a pity. And also, we know that it costs much more money to do it this way. So integrate acoustic design with your acoustic consultant at early stage is always safer, better, and much less expensive. And then the third part of my tips or advice is linked to the implementation of the solutions. You have a very good acoustic design, that's good, but it's only 50% of the success of your project. If you need to get a real comfortable and successful project in terms of acoustic, you need to pay attention to the construction documents and how the solutions are implemented during the construction. So that's it for my presentation. Please do not hesitate to ask questions. We will go to the question and answer session now. Thank you very much for listening to me.
Thank you, Jean-Philippe. We have a question that's not a poll. You can put it in the chat that I think everyone is very familiar with by now. Which topic would you like to hear about in our next webinar? So, as you know, this is not the first time we do webinar sessions. We are always very happy to know about interesting topics that you'd like to know about, whether it's architectural acoustics, industrial acoustics, or environmental acoustics. So feel free to share your thoughts in the comments, and we'll try to accommodate for everyone. And on the next slide, so we're going to go into the Q&A section. We're running a little bit late, so if you don't mind, we might extend a bit of time so we can answer as many questions as possible. Maybe around 5 more minutes so around 4:05 Vietnam time. And for those who cannot join until a little bit later, we will send you the replay after the webinar anyway, so you can watch it. Okay, so Jean-Philippe, first question. Is LEED credits on acoustics for new buildings sufficient if we do the open space of the office building? Will we get the LEED certification for the building if we only do the open space?
No, I mean, all certification, green building certification systems take into account acoustic, and usually you need to pay attention to all sensitive areas. So it won't be sufficient if you only treat one part of your project.
Okay, thank you. We have another question, which is low frequency versus high frequency noise. Which is more irritable or harmful out of the two?
This is a very good question. I would say there is no simple answer to that. It depends on people. Usually, wide range noises are more acceptable because we cannot identify the frequencies. Low frequencies can be more not damaging but annoying because we usually have more pure tones, so that's more annoying, like some ventilation or compressor noise transmitted through the structure of the buildings. And to be harmful, you need very high level. So generally speaking, inside buildings, I mean offices, hospitals, schools, we don't have dangerous levels because the danger in terms of noise level is more above 80 dB, which is very rare inside a normal building, except factories, of course.
Thank you, JP. There's another question which was related to your talk about flanking transmissions. What software do we use to predict the DNTW?
Oh, usually there are different types of softwares, but we at Delhom Acoustics we use Acoubat. We also have our own in-house software to calculate the flanking transmission. So there are different ways, but there are technical and commercial software that can help you to quantify the noise, the flanking transmission noise.
Okay. There's another question related to norms of calculation. Are the norms for calculation between Europe and the US similar?
Yeah, there are different standards, and it's physics, so the calculation it works everywhere in the world. I would say that between the different regions, it's not really about the calculation, but it's maybe about the criteria. For example, in America, we use more the STC. In Europe, it's more the RW, so it's different, but at the end, it's the same. It's just the criteria are a bit different. But usually now it's quite worldwide, and we work everywhere in the world, and it's not a big problem for us to adapt to the local standards or regulation. It's really very similar. We must remember that acoustics is a branch of physics, so the basic laws are the same everywhere in the world.
So you're saying that the law of physics are universal?
Yes. Thank you, Louis.
So next question is about the type of software we use for simulations for room acoustics. What kind of software do we use or programs?
So we use ODM, which is a very powerful software that can allow us to do a very simple meeting room, but also an opera house. So it's very powerful because it can give you very simple information or go very deep into the understanding of the sound scape of the room. So for an office or meeting room, we will focus mainly on the speech intelligibility or the reverberation. When we do a concert hall, we will go into more details, more information, more complex analysis. But the software, ODN, is the main software we use for room acoustics.
Okay. There's a question regarding different materials. What exactly is the difference in materials? According to physics, we need to catch half an amplitude in a gap between hard and porous microperforated surfaces. So according to this material, it doesn't matter as long as there are holes over 0.1 millimeter and a gap large enough for the frequency. So is this correct?
So you're talking about perforated materials. So in fact, when we use perforated materials, we use a physical phenomenon, which is called the Helmholtz resonator. It means that behind each hole, we have like a virtual cavity that will resonate and absorb the energy. So in fact, the performance of the material will be depending on the size and the length of the holes and the volume you have behind the holes. But if I understand properly your question, in fact, the physical phenomenon is a bit different. When you use porous materials, the energy, the sound energy, will be absorbed within the fiber of the porous materials, and we will transform it into heat. And in the cavity absorbers, the energy will be absorbed by resonance of the cavity. I'm not sure if I answer properly.
I think that was great. Thank you, Jean-Philippe. We have a lot of questions. So as time is running out, I'm really trying to really trying to answer as many as possible. If we can't get to yours, don't worry. We will get back to you via email if not. We have a question. Could you give some solution for VRF outdoor noise problem?
VRF.
Maybe VRV. It could
be. Yes. Yes. So for external equipment, yes, solutions. There are different types of solutions. First, we need to do the simulation to see, and it's very important to see how many decibels we need to gain, because if you are looking for 5 decibels, it's not like it's not the same solution as if you are looking to reduce the noise from 15. I will give you an example. If when you calculate the impact of your equipment on the site boundaries, for example, you realize that you need to reduce the noise from 5 decibels. A screen, acoustic screen, will most of the time will be sufficient. So you can have a certain distance between the equipment and the screen, so you don't have any aerotic issues. But 5 dB will be easy to reach with this type of solutions. If you are looking for something around 15 decibels, then it's more complex. So you can use silencers, you can use box around the equipment. You can also use location of the equipment to reduce the impact. So there are different types of solutions, and every time is different, and it will really depend on how many decibels you need to achieve in terms of noise abatement. So there is no one ideal solutions, in fact.
Thank you, Jean-Philippe. The next question is, what would you do at concept design stage of an acoustic design?
So this is very interesting, because for me, the concept is maybe one of the most important parts of the success of the project, because it's during the concept we will understand the needs, and we will translate all the needs of each space in terms of adapted acoustic targets. And also at this concept stage, we will provide not the solution, but the principles that will allow to achieve the targets. And it's important because if we realize that we at concept we need to treat the ceiling of a space, then it's the time to discuss with the interior designer or the architect to see what kind of what do they want for the ceiling and what can we do. But at this stage, it's very easy for us to give them the inputs, because most people will think, okay, we need to treat acoustics, so we will add ugly materials. But no, in fact, every material has some acoustic performances, and we can use wood, we can use concrete, we can use glass, we can use metal, we can use any types of materials. We can adapt them to give them some acoustic properties, but it has to be known at the concept, so we can orient our solution at early stage to comply with the design and with the acoustic requirements. If we don't do that at concept stage, it's sometimes too late, because the interior design will go on and some solution will be fixed and difficult to change or adapt in schematic or detailed design phase.
Thank you, Jean-Philippe. Maybe we have time for a last few questions. This one, have you ever integrated used environmentally friendly alternative acoustic materials in your projects? For example, alternative absorbers to replace rock wool. Do you have any strategy in this topic?
Yes, of course, and we do it more and more. In fact, taking into account acoustic in your project is sustainable, and we have more and more projects where we use sustainable materials. So instead of rock wool or glass wool, we use natural fiber like coconut fiber or vegetal fiber. We use, when we were talking about PET, PET is a fiber that is made of recycled plastic bottles, so it has a sustainable aspect. So we take this into account as much as possible, and there are almost always solutions that can be more sustainable than rock wool or glass wool, and we see it more and more in our projects.
Okay. Last question, and the rest we will send to you via email. Is it possible to estimate a cost of a currency times a square meter for a standard acoustic treatment for an office space?
That's it's a good question, but I'm sorry, it's very difficult to answer this question, because again, when you design an office, you will have in mind some finishes. You will have in mind some furnitures. You will have in mind, I don't know, plants. So you have in mind a lot of things, and acoustic is not something we add. In fact, as I said earlier, if you integrate the acoustic design with your acoustic consultant at early stage, it's a question of choice of materials and what kind of solutions you can integrate. I give you an example. You want to use a green wall. This is not acoustic, but it has acoustic properties. So this is something we take into account in our design. Or you decide that you have on one wall, you will have a huge artwork that could be completely acoustic, and this will not add any cost. You can have your paintings or your pictures on an acoustic materials that can be very cheap, like fabric, as long as you use an absorbent materials behind with the certain density and thickness, then you will bring some acoustic properties. The furniture, the choice of lightings can be part of the acoustic design. So if we take the example of an artwork made on a wall with acoustic properties, I would say the cost would be a few USD more than the normal artwork. So it's a very difficult question. If you decide to add acoustic solutions once the design is done, then the cost can be much higher. So it's really depending on the way you integrate acoustic. If you feel that the acoustic design is part of the design, then the cost can be really minimized.
Okay, fantastic. So since we're running out of time, I just mentioned in the group chat, a lot of people are asking whether we can get the link for the recording, the replay. So Everyone who has registered to the event will receive the replay of this webinar, and we will go through all the Q&A and answer those questions. That might take a little bit more time because there's a lot of questions, but we will. And we really want to thank you for these questions you've asked. If you go on the next slide, JP, we will be able to show you 2 ways to get in touch with us. So first of all is the contact email. So if you have questions or if you want to discuss more, if you want to organize private workshops as well, feel free to contact us. And if you want to follow more about our company and learn about acoustics, as we regularly post on our social networks and on our website, so you can scan the QR code over here. So again, replay will be sent to you, and I'm very happy to see the positive feedback from all of you in the comments. We hope that we can see each other face to face at an event one day. So, and keep posted for the next webinar. Thank you, Jean-Philippe, for your time as well.
Thank you, everyone. It was my pleasure to share with you my experience.
All right. Have a great day, everyone. Good morning and good afternoon to all of you.
Thank you very much, everyone.